Okay, I wanted to do one more video with just a few more examples of adding and subtracting rational expressions with unlike denominators. This is just a few extra examples. You probably need to watch the other video on this first, and then this is just some, like I said, a few extra examples if you're still having some troubles. Okay, I'm going to do, we'll have x over x minus 4 plus 3 over x minus 1. Let's make that 3 over x plus 1. Okay, so the first thing that I would do is factor the denominators if possible. Neither one of these denominators will factor, so we can move on to step 2. Find the least common denominator. The least common denominator is made up of the highest power of every factor from these denominators. So I'm going to need an x plus 1 and I'm going to need an x minus 4 in my common denominator. The next step is to rewrite fractions with that new common denominator of x plus 1 times x minus 4. Okay, on this top fraction you see we already had the x minus 4, so we must have multiplied that by x plus 1 to get this. We'll have to also multiply the top by x plus 1. You want to make sure that you distribute here, so you're going to get x squared plus 1x, or just x. On the bottom we had the x plus 1, so it got multiplied by x minus 4. We'll multiply the top by x minus 4 as well. We'll distribute the 3 through that binomial, and we'll get 3x minus 12. The next step is to combine your numerators and put it over the least common denominator. So if I combine my numerators, I do have some like terms in my numerators. So when I combine those, I'm going to get x squared plus 4x minus 12 all over the common denominator of x plus 1, x minus 4. The next step says factor the numerator if possible. This numerator will factor. We're looking for factors of negative 12 that add to get positive 4. That would be positive 6 and negative 2. And for a minute I thought I made a mistake, because I looked and I thought, well, none of these are the same. And that's okay. This is our final answer. It will not simplify. But the only way for us to find out if it was going to simplify is to factor the numerator. So that's a necessary step. You need to factor the numerator if you can, because that will be the only way that you see if your numerator and denominator have any common factors that you can cancel out. And in this case they don't, so we're finished. That is the end of that problem. Alright, let's do another. X over 3x minus 9 minus x minus 2 over x minus 3. Okay, so step 1, factor the denominators if possible. I wish I'd left myself a little more room here. This one will factor. We can factor out a greatest common factor of 3. This denominator will not factor, but while I'm at it, I've seen this negative sign out here and I don't want it to get left behind. So I'm going to go ahead and make that a positive and distribute that negative through the numerator of the fraction that's being subtracted. Okay, now I'm looking for my least common denominator. Here I have a 3 and an x minus 3. Here I just have an x minus 3. So I'm going to need both of those factors in my least common denominator. So I'm going to do step 3, rewrite my fractions with that common denominator. Okay, this one already had that denominator. So since the denominator doesn't change, the numerator doesn't change either. Down here, we multiplied by 3. We're going to have to multiply the top by 3 as well. And we're going to distribute that out. 3 times negative x is negative 3x. 3 times 2 is positive 6. Now notice how we multiply out the numerator, but we leave the denominator in factored form. Okay, that's important. We don't want to multiply out the denominator because we'll just have to factor it again at the end, and so we would just be making more work for ourselves. So leave the denominator in factored form. Now we're going to combine our numerators and put it over the least common denominator. We do have some like terms we can combine. A 1x and a negative 3x gives us negative 2x plus 6 over 3 times x minus 3. Now on top, we can factor out a greatest common factor, and anytime our first term is negative, we want to factor out a negative greatest common factor. So we're going to factor out a negative 2, which is going to leave us with x minus 3. And down here we have 3 times x minus 3. And you see then that we have these like binomials we can cancel, and our final answer is actually negative 2/3. All right, one last example for you guys. We have 4n over n minus 8 minus 2n minus 1 over 8 minus n. Okay, now we have talked about how n minus 8 and 8 minus n are opposites. Okay, if you multiply one of them by negative 1, you get the other one. Or if you divide n minus 8 by 8 minus n, you get negative 1. So that's their relationship. When you have opposites in your denominator, you can use either one of them as your common denominator. I'm going to choose to use n minus 8 just because I like the variable in front. That means my top fraction numerator will not have to change. Now, to get 8 minus n to give us n minus 8, we would have to multiply it by negative 1, since those are opposites. And that means I would have to multiply my top by negative 1 as well. Before I do that, I just noticed this. I'm going to go ahead and bring that through that numerator before I do this step. Alright, negative 1 times negative 2n is positive 2n. Negative 1 times positive 1 is negative 1. Now I'm going to combine my like terms in my numerators to give me 6n minus 1. Put that over my denominator. Factor your numerator if possible. Not possible. So we're finished, and that's our final answer.